So we're still in the middle of this hypothesis test from this computer output that we have here. We're trying to see if using your cell phone impairs your reaction time. That is, it makes it longer or makes it take longer for you to react to things while you're driving. So we have answered all these questions about the outputs. We figured out our hypotheses and our test statistic. And now we need to figure out step 4 of the hypothesis test method. And we're using the p-value method here. So we would draw this lovely curve right here. And then our test statistic is negative 5.46, which is really, really low. And I almost drew it to scale here just to show you how far off the regular curve that is. And that p-value is really, really small as well. It's less than 0.00001, 3 zeros. So you can see it's very, very small, so minuscule that Minitab basically just calls it 0 and calls it a day. All right, so there's step 4. We did that. We drew our normal curve, or actually our t-curve, with degrees of freedom equal to 31. And then we put the test statistic over here on the left and the p-value there. Now, if the researcher had set alpha to be 0.05, would those results be statistically significant? Well, yes, absolutely, right? Because our p-value is less than alpha. Remember that you reject the null hypothesis when your p-value is less than alpha. Let's see, let me bring up the test we're doing here. So we reject H0 if the p-value is less than alpha, always. So this would be a big fat yes, right? We would reject H0 because the p-value is less than alpha. This is statistically significant. Remember that when we ask if something's statistically significant, what we're really asking is, would you reject H0? Right? That's what we really want to know. Those two things go hand in hand. Leaving the null hypothesis in place is not significant at all because you assumed it to be true. It's only significant if you can get rid of it, if you can say that you didn't have enough evidence to support it. Speaking of which, there is plenty of evidence to support the claim that using cell phones impairs reaction times. Impairs, i.e., in other words, the sample data supports that driving reaction times are longer, which is not a good thing when using cell phones. All right, so we finished off that hypothesis test. Keep in mind, I could actually ask you to do the classical method if I wanted to. That would have gone a different direction. Instead of using the p-value from the computer, we would have had to find a t alpha based off our degrees of freedom, n-1, and then reject it if our t-score, t0, was less than negative t alpha, which of course it would have been because our t0 was so low. It's at negative 5.46. All right, we're going to stop right there. I know this is a really short video, but the next one's going to have to deal with the confidence intervals, and I don't want to get ahead of ourselves. So let's pause right here, and we'll talk about confidence intervals in the next video.